I'm your teacher Ibrahim. This is lesson number 10, the practical lesson, whereby I'm going to talk about the test for non-reducing sugars. Non-reducing sugars is a type of carbohydrate which is referred to as a disaccharide, and it is present in foods such as sugar. It is also present in honey. They are characterized by a sweet taste. Hence, when they dissolve in water, they provide a sweet tasting solution. I'm going to conduct the test for the same and reducing sugar, and I'd like us to check on these. Whatever I need for me to test for it is the measuring cylinder. I need to have the substance to be tested. I also need to have hydrochloric acid. It should be dilute for that matter, for efficiency. I also have Benedict's solution, and finally I have sodium hydrogen carbonate. I'm going to run both negative and positive tests for the same concurrently so that we can be able to compare the two. I'm going to have two boiling tubes, one for the positive result and another one for the negative result, so that we're going to see how the two are going to be visible. Let me just try it. Procedure number 1. Put 2 centimeter cubed of the substance to be tested, or the solution to be tested, in a boiling tube. My substance to be tested here for the positive result is here. Okay, let me just measure it. That's almost 2. Let me add some little bit of it. That's exactly 2. I'm putting it in the first one that tells me that it's the positive test. So this one has that substrate. And another one for the negative test, I'm going to use water, 2 centimeter cubed of the same. Let me just clean it. That is 2 centimeter cubed. Then procedure number 2, add 3 drops of dilute hydrochloric acid. The dilute hydrochloric acid is meant to break the bonds which are found between the disaccharide molecules. Remember, I said that the disaccharide molecule comprises of 2 molecules of monosaccharides, and therefore in between them there are some bonds which are referred to as glycosidic bond, and therefore upon adding 2 to 3 drops of dilute hydrochloric acid, I'm going to heat it so that it can boil and those bonds will be broken down. There we go. Let me find the hydrochloric acid. Hydrochloric acid, it's here. I think you can see my label there. It has been written hydrochloric acid. I'm going to add 2 to 3 drops in each. 1, 2, 3. Let me just hold it well so that you're able to see what I'm doing. I'm adding 3 drops into this as well. 1, 2, 3. I've added 3 drops in each. So the next step is heat to boil. Then after heating to boil, I'll go to the next phase. There we go. I'm now heating the mixture. The solution is already boiling over here. I think you can be able to see. Good. After boiling, the next procedure, that is number 3, cool the mixture. I'm placing it in a beaker containing some cold water for the sake of cooling. Once the process of cooling has taken place, then I go to the next procedure, the next part of the procedure for that matter. That is, add sodium hydrogen carbonate till fizzing stops. The reason as to why we are adding sodium hydrogen carbonate is to react with the acids which would have been left within in the solution. During that reaction, there is production of some small bubbles. I call them effervescence. When that effervescence is being produced, there is some hissing sound which could also be produced. We call it fizzing. So we are going to add sodium hydrogen carbonate till fizzing stops. I have a dropper with me here. Then this is sodium hydrogen carbonate. Let me shake it. Let me shake the sodium hydrogen carbonate. I'm going to add it till fizzing stops. There we go. I'm adding it in the first one, that is for the positive one. Adding, I think you can see effervescence being produced. That process is referred to as fizzing. So I'm supposed to add until the process of fizzing stops. You can see it is now reducing in intensity. So we say that the process of fizzing is almost stopping. I'm still adding some more, some more, some more, some more. No more fizzing. I want to be sure that fizzing has completely stopped. You can see there's no more fizzing. Then I can leave it at that point. Go to the next one again. I'm going to add to the one that was to be negative. Remember, fizzing is taking place just because there was hydrochloric acid. So that is the... Yes, the reaction still taking place. You can see the process of fizzing still taking place. Yes, it's almost stopping now. Just adding until I see it stop. Yeah. So it has stopped. Let me just add to be sure. Good. The process of fizzing has stopped. Then I'm going to move to the next procedure. That is procedure number 5. I'm supposed to add equal amount of Benedict solution, then heat it. Benedict solution will now be in a position to react with the non-reducing sugars. The reaction take place and we'll have the results as required. I have my Benedict solution here. There are some that I had already placed in the measuring cylinder, but it seemed to be too much. Oops, I've just reduced it to 1 cubic centimeter. Good, I'm good to go. So this is my 2 cubic centimeter of Benedict solution. I'm adding it in both the two setups, that is A and B. That is A, that I call positive setup. I'm supposed to put another one here so that they can run concurrently. Let me measure some and see. Same setup, there we go. So I have 2 centimeter cubed of Benedict solution together with the mixture, and I'm going to the next phase whereby I'm going to heat them. I am now supposed to heat the mixture until boiling starts to take place, when I'll be able to see changes taking place. I've placed them on the source of heat. Remember, one is positively, one is going to give me a positive result, while the other will give a negative result. In case of a positive result, there should be color change, which should start from the blue one, the current one, then it goes to yellow, then the color should change to orange, and finally brown. If we will be able to observe such kind of color changes, then we are going to conclude. When you look at the one on the right hand side, that is the positive one, the present one, you can realize that the color has already started to change into green. If you are keen enough, I hope my cameraman is going to zoom in. You can see the color is changing yellow. It is between green and yellow, and the change is still taking place for the positive one, the one that I'm holding with my right hand. As you continue looking at it with a very close range, you'll realize that the color is now changing orange, especially the superficial part, and now it's changing to brown, which marks the climax in changing of this color. I think you are able to notice that. Just look at it closely, look at it keenly. You're going to realize that the orange color is now darkening and it is starting to become brown. When that happens, that it makes me to conclude that for a positive result, we should be having such kind of changes like the one that I'm holding here. I think you can see here I got present, meaning it is a positive result. And for the positive result, the color should change to green, yellow, orange, and finally brown, the way this one has changed. While on the other hand, I'm having another one on my left hand here, whereby the blue color persisted. So the conclusion should be the blue color persists, or else you can say that the blue color remains. That was the 10th lesson, whereby we were looking at test for non-reducing sugars, and we have been able to obtain our 2 results. And therefore, in our next lesson, which will be lesson number 11, we are going to look at another type of substrate, which is called starch. We'll be testing for starch in my next lesson. Thank you so much for viewing this video, and I believe that we are still going to learn more.